find the volume of the solid of revolution obtained by rotating the region that's bounded by the graphs of y equal to square root of x plus 5, y equal to the square root of 5 minus x, and the x-axis, as this region is rotated about the x-axis. So we're going to need a rough sketch of the region, and that would give us some idea what the solid of revolution looks like. This is the graph of the square root of x plus 5 function. This is minus 5, and this is the graph of the other radical function. That would be square root of 5 minus x. And so the region in question here has the border square root of x plus 5, square root of 5 minus x, and the x-axis. So the region is right in here, and rotating it about the x-axis will yield a solid that looks something like this. As you can see, this solid is symmetric with respect to the y-axis. That is, half the volume is generated by rotating the region to the left of the y-axis and half to the right of the y-axis. We're going to use that symmetry, at least we can use that symmetry, to find the volume. All we need is to find the volume of half of this solid, and we'll take the left half. So this is minus 5. This is the graph of square root of x plus 5, and the rotation is about the x-axis. This is what half of the solid looks like. So I'm going to take a typical x between minus 5 and 0, take the small interval that contains it. The length of that interval is going to be delta x, and rotate that vertical slice about the x-axis. It generates a disk. So let me turn that disk sideways, examine it, and here's the disk that we have. Give it a little bit of thickness. The thickness is what we call delta x. So this is delta x. And the base of it has a radius y, where y is the y coordinate corresponding to the x coordinate we selected. So delta v is the piece of the volume associated with this x. So it looks like this. It's pi times y squared times delta x. But y is the y coordinate on the graph, so y must equal to the square root of x plus 5. So squaring square root of x plus 5 gives us delta v is approximately pi times x plus 5 times delta x. So now the actual volume of the solid will be 2 times, 2 is because of symmetry. We're doing half, the integral will give us half the volume, 2 multiplying it by 2 will give us the entire thing. Then we have pi, the integral from minus 5 to 0 of x plus 5, and then writing it in integral for integral notation, delta x is replaced with dx. So this is an easy integral. It's 2 pi times 1/2 x squared plus 5x, and this is evaluated from minus 5 to 0. Plugging in 0 is going to give us 0, so we can write this as equal to 0 minus, now let's plug in minus 5, so we have 2 pi in front. Minus 5 squared is positive 25, so that's 25 over 2, and then minus 25. Now 25 over 2 minus 25 is negative 25 over 2, so this is minus 2 pi times minus 25 divided by 2. Our final answer then is 25 pi units cubed. Now we can find the volume directly without using symmetry. So the direct computation would be pi times the integral from minus 5 to 0 of x plus 5 dx. That's going to be the part of the volume to the left of the y-axis, determined by the region to the left of the y-axis, plus pi times the integral from 0 to 5, and that would be 5 minus x dx. That's the part of the volume to the right. So let's evaluate these. We already did the first one. It's pi times 1/2 x squared plus 5x evaluated from minus 5 to 0, plus pi times 5x minus 1/2 x squared evaluated from 0 to 5, and you can see we get the same answer. Plugging in 0 into the first one, we get 0 minus pi times 25 over 2 minus 25 plus pi times, plugging in 5, we get 25 minus 25 over 2, and then plugging in 0 would be 0. So this is 25 pi over 2 plus 25 pi over 2, which is 25 pi, obtained the same. We got the same answer as before.